In the geometry step, we specified the geometric parameters appearing in the mathematical model. To see what else we need to specify in the mathematical model, let's go back to one of the pre-analysis slides. So the mathematical model is based on the potential energy, and in particular, ANSYS needs to be able to relate the pin displacements to the potential energy. Now, to go from the pin displacements to the axial displacement of each bar, you can do that using, you need the geometry of the midlines to take the the cosine theta and the sine theta, as we saw in the pre-analysis. So it has that information from the geometry. And then once it has the axial displacement d to calculate the strain, it needs the length of the members, which has been specified. Now, to go from the strain to the stress, it needs the Young's modulus E, which we haven't specified yet. So let's specify that. And that's, that ANSYS gets from the material. So if I highlight line body and look down here, the material assignment by default is structural steel. And if I want, and let's take a look at what the Young's modulus is for Poisson steel that ANSYS uses. So I'll go here. In fact, I was playing around with this. So you'll see something like this. And if you double click on engineering data, and you see only one material is defined by default, structural steel, and that has 200. This is essentially 200 gigapascals. So ANSYS has the right value of the Young's modulus. So I can just get rid of that. Otherwise, I would have to create a new material and assign it. And if I go back to the slide, okay, so the Young's modulus is specified, and then to go from the stress to the force in the member, it needs a cross-sectional area, which also we have specified. Now, to go from the force to the potential energy, let me go to another slide, okay? So now it has the information to calculate the potential energy for the members from the pin displacements, but there's also a contribution from the external force. So let's specify that external force. Highlight static structural, and then say select loads, force, okay, and select that vertex and say apply, and I'll say components, and the X component is 1200 newtons, the Y component is 0, and Z component. So ANSYS is including displacements, and it's again a generalized mathematical model. It says that each node can move not only in the X and Y direction, but it can also move in the Z direction. So it includes that in the potential energy formulation. We can ignore that. That's 0. Okay. So the force is specified, and if I go back to my slide, then it looks like it has all the information it needs to calculate the potential energy of the truss from the pin displacements. What is remaining is that to specify the known displacements. So the some of the displacements are known from the boundary conditions. That's what we'll do next.